What if one of your students can't be bothered about all the things that I said was important just earlier? What I mean is, this student doesn't care about the real life use of mathematics, or how it helps us develop logical thinking and see the world in a different light. He even doesn't care the relationship between the various realms of mathematics. All he wants to do is to pass his math exam and move on with his life. All he wants is to have the skills required for him to score as high as possible in the exams. In a counseling session just today, such a student came to me. He claimed that he studied extensively, but he always performed poorly in his math exams. When any student expresses their symptoms, I start to ask various questions in order to come to the correct diagnosis. He knew arithmetics. In fact, his mental calculation skills were very good. His problem actually began starting from geometry, as his original complaint was that he could not memorize the formula, and thus in the exam he would be unable to use those formulas correctly. So I asked him, what does the formula a is equal to a square represent? Now I was asking him totally out of context. He could not answer. He had heard about the equation, but he did not know where it belonged. So I asked an easier question. What does a is equal to pi r square represent? Again, he could not associate pi with the circle and the a square with a square shape. Now I was understanding that he thought that all he had to do was to memorize the rules and practice, and then he could excel in mathematics. It did not occur to him that he had to understand the formulas. It's obvious that he did not understand what the algebraic formulas looked like on a Cartesian graph. He did not know that any formula was about finding the value of a variable by knowing some other variables. Anyways, I was able to help him by answering his particular query about binomial equations from the binomial theorem. As I was going through the equation, I asked him what a certain notation C bracket n comma r meant. He said that he just didn't understand, and thus it was very difficult for him to memorize it. Slowly I helped him see that there were two parts in the binomial theorem. One was pure algebra, and the other was from combinatorics. Algebra part he understood, but somehow he was unaware about what the notation C meant. What had happened is he was absent for 3 days, and he missed that particular class. Still worse is that he did not know that that chapter on permutation and combination had been covered. So I told him that in order to understand binomial equations, you must first understand the formula of combination that comes under the chapter of combinatorics. The algebra part you already understand. Nobody had told him that. Yes, he did not know that in mathematics, if you do not understand a certain step or a certain part of a formula or a solution, it means that you have missed an earlier chapter in which that step or formula was taught. So the logical solution is to go back to where you missed the step, learn that, and then solve the problem in hand. Sure, it might take a longer period of time, but this is how you score high marks in mathematics. You don't need to know the history of algebra or calculus. You don't even need to know the application of trigonometry in daily life. You don't even need to be convinced that mathematics is equivalent to doing push ups for the brain, but you definitely need to be able to go backward when you don't understand and then forward once you understand. So, this student finally got the epiphany of forward, backward, forward strategy of problem solving. I told him that it was not only to solve this particular binomial theorem problem that he was facing, but it applied for everything about mathematics. In fact, that is the beauty of mathematics, that by simply knowing the strategy of forward, backward, and forward, one can score a plus in math very easily. It is keeping in mind students like that I have come up with this particular table that you can see in the diagram. It consists of the 13 components of mathematics that we discussed earlier on. As I mentioned earlier, these are all the components that are taught up till grade 12. It's placed in one single page. Students like the earlier one can then go into each box and go through the various rules, definitions, formulas under that component. If he knows what it is about, then it's good. It's a pass. However, if he doesn't know what that particular rule, formula, or definition or classification is about, then it's bad and it's fail. Without knowing that particular components, subcomponents, he will not be able to understand the next component or higher realm of mathematics. It starts from the numbers theory up till calculus. So if the student isn't aware of certain rules that are mentioned in this table, then he should go on YouTube or use artificial intelligence to understand it, practice it, and be confident about it. You can confidently say that if you are proficient in those 13 components and all its subcomponents, then there is no mathematic problems that you cannot solve, even those of pure mathematics and engineering problems. It will take you some time to understand the problem and the formulas involved as well as the process, but the modules required to solve even the most complex problems belongs to those 13 components. So this particular model is very powerful. I've already talked about it at length in the earlier section, but I will just repeat that it's an amazing innovation whereby you can see both the trees and the forest in one shot. I am so happy that students will have this tool in their hands because of my research and the publication of this book. It might not be this year or even in the coming 10 years, but no dark cloud can obstruct the light from this book forever. In this, I relish. You might call it a delusional thought, but I like to think about it as a prophetic thought. In my counseling session today, this 13 component model of mathematics helped me quickly make the diagnosis of what skills the student was missing. In fact, I will have lots of opportunities to test my own model before the world would get hold of it. I'm sure that by then I'll be ready to defend and promote my four brain learning approach to mathematics. Let me go through each of the 13 components very quickly in this subsection. The objective is just to help you get a quick view of the trees along with the forest. It's not me who should be saying this, but this concept will revolutionize the learning of mathematics one day. So first, This table consists of numbers, this classification and the definitions. Then it talks about groupings and symbols and various operators, their properties, rules, and classifications. Next, we talk about the plus and minus, their rules and properties, followed by the multiplication, their rules and their properties. Then in the fifth component, we talk about fractions, ratios, percentages. I'll be talking about their definitions, classification, and rules. Then we talk about compound interest, the classification, rules, definition, and formulas. Set theories, definition, classification, representations, and tools. Then we go into mental calculation versus calculators, the various strategies. Then we talk about geometry, the definition, rules, classifications, properties, and principles. Algebra and coordinate geometry, the definitions, classifications, rules, properties, and formulas. Then we go into combinatorics, their classification, definition, rules, and concepts. Then trigonometry, its definition, rules, identities, laws, and formulas. Finally, we get into calculus, the definitions, the theorems, the rules, the applications, and the tick. Finally, we'll talk more in details about each